foreseen it is going. Now you don't need to waste it by paying ad spend and test variation from getting 50% of your users' worst experience. Go with the optimized Are you starting to close the testing? Maybe, but the other, the flip side of that is you're saying some of the largest companies in the world, anyway, all of the very smart people come up with this is the way to do it. I think that's a big statement to me. Yeah, it is. But what if it's right? Because very good on Meetup.
Yeah. Well, and if it can, I can expect Google to try to jam the cease and desist down my throat because they're losing X% of ad revenue. Less testing.
Oh, it's the cease and desist.
No, I'm joking around. It would be to say, which would not be a terrible idea. It would be that's costing us, so it's either CD or buy my software.
Excuse me, everybody. Excuse me, while the iPhone.
Yeah. You connected on LinkedIn? Yeah.
Woo! Hello! Hi, everyone. Okay, thank you. I'm going to pull your attention in this direction for the next, about 20 minutes. My name is Anushka. Jake usually does this. He could be here today, so I'm here instead. Wildly Eye, if you're here for the first time, is a free and open space for people to come talk about AI, talk about what you're building. This is the rarest type of tech event you will ever go to because there are no slides, there are no visuals, there are no demos, no promotions, no pitches, no selling. We're here to talk. We're here to talk about what we're building. We're here to talk about what we're working on, what we're learning. The format is simple. Speak up, ask questions, and say the thing you want to say before you think it's smart. So what we're going to do is we're going to have a lineup of 3 speakers. They're going to come up, they're going to talk about what they're working on, and I want to jump right into it. So our first speaker is Urbis Eka. Urbis is a machine learning engineer. Urbis has worked at NASA. He has worked in alignment research, and currently he's working at a very interesting organization. Urbis, if you're here, I'll call you up. Please give a round of applause for him. He's going to be talking to you for the next 5 minutes.
I think the NASA thing a little bit of a stretch. It was like through like a student organization project thing. Okay. Hi, I'm Urbis. I work at RSVP, where we're building AI-powered tools to help cybersecurity teams. The topic of my talk is synthetic data generation, benefits, pitfalls, and possible solutions. So why even bother with synthetic data generation? It's cheap and it's fast. So if you take for example a moderately sized data set of 1,000 samples, it would cost like $20,000 to have a human team annotate that, and about 25 working hours, as opposed to like having an LLM do that, which would cost around $200 and about an hour. So does synthetic data generation have no downsides? That is definitely not true. The biggest downside is with respect to quality, and this often shows up in non-obvious, insidious ways, particularly in downstream model performance. Specifically, it shows up when the model hallucinates and with distribution shifts. I'm sure everybody here is super familiar with hallucinations, but it's just when your model is wrong. But distribution shifts are when the data you train your model on is different from the distribution of data your model will encounter when deployed, i.e. real-world data. So let's tackle this one at a time. The way you can kind of fight hallucinations is by grounding it in real-world knowledge, and the easiest way to do that is to or what we've found is by extracting discrete knowledge statements from documents, and that's kind of exactly what it sounds like. It's just RAG. The way we kind of changed it to make it a little bit safer for us is we embed citations. So each chunk has its own unique ID, and we embed that in the metadata of the sample that we generate, and then we cross-reference that in the verification step, making sure that the citation is what the citation claims to be, and that the knowledge statement in the sample itself is semantically equivalent to the chunks that we pull. Further, we also have a quality verification or a quality check-in step where we pass the sample through a panel of 5 LLMs as judges, each rating on a different criteria. Then we have like a weighted average of each of those grades, and depending on the score, we either keep the sample or we iterate further. So in my opinion, the hallucination is like pretty straightforward to actually get through. It gets kind of nasty when you're doing or trying to fix distribution shifts. So it kind of breaks down into 2 parts, the what and the how. So the what is like, what are real world data sets actually asking, or what are humans actually asking of your model? So in our case, we're building like a cybersecurity specific model. So what are regular cybersecurity professionals or hobbyists asking LLMs? And to do that, we first define a exhaustive ontology or like taxonomy over the entire field of cybersecurity. And we use this ontology to label different posts from common question and answer sites like the Information Security Stack Exchange or even Quora. And this kind of gives us a good distribution of like a solid amount of data to kind of work with, to seed our samples with. And beyond that, we also get like this bonus data where we have categories of, or different subcategories from our ontology, and to check where they actually overlap. So like multiple categories asking the same question. And so that gives us like these clusters that are really helpful to like deal with separately. So that ontology gives us the what, but that doesn't really help us with the how. Or another way of phrasing that is that it doesn't really help us with the semantic form that questions take. And that's really important to deal with because otherwise your model's going to overfit to overfit to synthetic patterns, which is like not good at all, right? So one way you can deal with, or the most rigorous way you could deal with that is through like a GAN style setup where you have a discriminator as a classifier that is trained to differentiate between real and synthetic data, and you use that or use the output of the discriminator as a reward signal in a reinforcement learning environment. In my opinion, that's like really overkill for like a small part of this whole pipeline. So an easier way to do it, even though you're cutting the quality a little bit, is to just train a very simple classifier to differentiate between your synthetic and your real world data, and then just have it as a filter over your entire data set that you generated. And it doesn't have to be super complicated or super elaborate, especially because in our case, our data set will be quite small. So as long as it can filter out the worst of the worst, for our fine-tuning purposes, it should be fine. Yeah, so if that was my talk, but if you are interested in Hacker Sidekick and you want to learn more, or you would be interested in it as a product, you can talk to me, or you can talk to Amir in the back. Yeah, any questions? Yeah, any questions?
Any questions?
Yeah.
Yeah, are you generating the synthetic data to train models that you will use, or are you generating the synthetic data to sell to third parties?
We're gonna train a model. We're gonna fine-tune a model with the synthetic data that I'm generating, and we're gonna release the model. Essentially.
Okay, but still though, you can't create information, right? So why not just fine-tune the model with the original data? How does creating the synthetic data help?
It learns better. The learning signal is better, and it's better for instruction tuning. So like, we're building as a chatbot, or we're fine-tuning a chatbot. And ideally, it would be really responsive in that chatbot format, as opposed to like just wholesale. So there's like we're drawing information from many different types of documents. So it's not just like textbooks. It's also like DEF CON presentations and DEF CON worksheets and like stuff that's not in a very ingestible format, at least like as it is. So we need to like manipulate it at least a little bit. Yeah.
How do you feedback in like more real world data? Like how do you know when you're like kind of done with when you feel like it's good enough? Like what's the balance that you be like more like your problem solving? It's like criteria between like synthetic and then more real world, and then like what happens when you get more like real world data? Like do you run it back to the existing data?
Sorry, could you repeat that? I can't really hear.
Sorry, I'll yell more. I'm usually pretty loud too. Yeah, how do you do like the life cycle of your model? I guess is like the rest of the question.
Yeah, that's a good question. Right now, we're just like trying to iterate really fast and try to get to a point that we're like satisfied with, just like as a company as a whole, like our internal team. And we're not at that point yet. I think like some good like benchmark. We have a couple internal benchmarks where we have some vague idea of what we want. But the North Star is just better than foundational models. That's really the only thing that matters. And once we've hit we are consistently better than foundational models on all our benchmarks, then I think we're good. Yeah.
What are you classifying as like your evaluation of benchmark experts? Is it the ability to help cybersecurity advisors with their questions?
Yeah, that's a good question. Right now, our evaluations, a lot of them are like cybersecurity specific knowledge tasks. There's a couple like agentic you may have heard like CFT. There's like a like capture the flag eval. So that's like more agentic. We're also using that. But we also have like some internal ones that are a little more like combination of agentic and something like more real world where it's like chat oriented essentially. Like they're like chat completion. Yeah.
Sorry, can you quickly come again? So are you focusing on building things that can code better, more penetrating, or more like?
It's supposed to be a general purpose cybersecurity. So essentially, like think of it as, like you can code. It can you can ingest CVEs or whatever, like hex codes and tell you all the relevant information. Thank you.
Okay, all right, that was great. Thank you, Orbis. Our next speaker is Sarah, and I'm going to read this out because this is like something from Star Wars. Sarah is a professor associate at the University of Paris-Saclay in France. She's working on time domain astronomy to detect the most explosive events of the universe, thanks to the help of AI to detect those rare events. And to organize smooth observations with citizens and academia in a race over time to analyze the data from a plethora of various captors. I'm very excited to hear your talk, Sarah. Come on up.
Okay, hi. So I'm very happy to be here. I am with my colleague Michael Consling, who is from University of Minnesota. So I am, as you said, an astronomer, but I am also manager of networks of telescopes, about 35 telescopes all around the world, from China to United States. And so what we do is we try to detect the most exploding events of the universe. What it is linking to you is that these exploding events tell us about how the Earth is made of, for example, uranium, etc., are built in these exploding events. The problem is that if you are looking at the most exploding events, it means that there are very, very rare events, and there are many, many things that happen in the sky, and so we don't want. For us, it is not. So the problem for AI is because we need to detect anomaly over the sky, so with image. And so because you said this happen maybe right now, in a certain position over the sky, we need to have a race over time because it will shoot a new star, let's say, but then fading. Its luminosity was fading, and we need to shoot with multiple telescopes all over the world before it's fading. So we have the problem of vision, detection of anomaly. Is it a real event in the sky, or is it like just some bug or some artifact or some minor planet or something from Starlink? I don't know what, Second is, are we gonna observe with new facilities And so for that, we need to trigger a campaign. Right now, it's dark in Minnesota. I think there are clouds, so you're not going to observe, so you need to trigger facility right now in Chile to catch the lights and get more and more information. So what we get as the input is a time series. So it's how the new sources is preparing over time. And we would like to understand, as the previous talk, what is happening, what is this thing? Is it an exploding event or not? Is it an exoplanet or not? Okay, so we have this kind of classification over time, and this is the second topic, it is classification. And because I say that we are triggering facilities, I talk about that I'm running like 35 telescopes, but all of you, if you have a telescope, or if you have just a computer, you can be citizens and also participate to the vetting. This is what we call citizen science, and this program has been endorsed by NASA thanks to Minnesota. And so they are already amateurs, so not you, but maybe you tomorrow, that can take data or vet or help to investigate what the universe is made of. And so why I talk about the citizens is that we have professional, amateur, all of that label, that discuss, that blah blah, like, etc. And so we need to guide them, okay? And so this is why we have LLM, to try to mimic all the experts. Because imagine that I'm crazy, there is one event right now, in the next hour, another event, etc. So I cannot sleep, because, we need to take observation all the time. So we need to have AI coming. And so my conclusion is why? Is because there is a beautiful telescopes, 99 maybe % USA funded, that's called Verabin. It is the most expensive ground telescopes never built. And you will observe the sky like this and detect so many new things, so many minor planets, so many things, and maybe exploding events, I hope so. And so these telescopes will be fully operation this month. And so we have a huge data problem, because before I was just in peace because it was just like one rare event per 1 week. But now we will have so many noise and anomaly that we will need to vet and getting crazy about 100. So it's a change of scale for us. It's a change of scale in terms of infrastructure. Okay, so I don't know how many time I have. I'm speaking fast. That's good. Okay, so in France, we try to make the bridge with you, the industry, with computer scientists to solve our problem, because we have so many data, it is our data, and so the computer scientists say, okay, let's plug in with this dreamer astronomer to help them about the infrastructure. But also the companies say, yes, it's also a great problem to solve. How, for example, if you want to test hallucination, things like this, how to test in your model. There are so many companies that develop their own classifier, but who is the one that will challenge the thing that we talk about these telescopes? And so this is the point why some French industry are there, and so that's why maybe some of you will be interested to also partner with us, with academia. So this is the point. Well, so I think I have finished, but if you want all our, challenging, because we have so many challenging, just discuss with me on this mic.
What type of thing are you trying to classify first out of like what you're getting out of Vera or any of the telescope networks? Like what type of target are you looking at?
Yeah. So we have, as I say, conversation, we have the text, we have image, we have spectra, I don't know if you think, like we have time series, we have multimodality things, but the problem is that the information comes asynchronously, so because, I just talked about the optical because it was easy for you, but we have data from other messenger of the universe, so we need to grab all this information to understand what it is, so I hope so too.
When you say you're looking for help, what are you looking for?
Well, many things. We have a problem about first, we are researchers, we are academia, which means that we are building things with our students. The students are physics profile. They know how to do physics stuff. But the data scientists, they are good, but we try to make the bridge with them, but it's all academia, which means that we need pipelines that make operation, we need to scale up to operations. This is number one. Number two, for AI, we are looking for help maybe on the detection anomaly of a space. There is some space companies are looking for space survey and space, for the army and space to identify the debris and things like this. So this is the same problem. And we have some problem. Why? Because one day it's one telescope that takes that, few hours another telescope, so there is a problem about capture and bias between the different measurements. And we have so many problems. And we have some problem about the stream that we talk about, and the classification, multimodal classification, things like this. I don't know if I answer into details, but Michael had just close to you has all the list.
Thank you, Sarah. And thanks for introducing all of us to the term citizen science. Yes. There are a lot of people who don't have PhDs and they want to do research and they think they don't have a pathway to do that. So thank you.
I can point to the website.
Yes, definitely. Okay, our last but definitely not the least speaker is Andrew Dahlberg. Andrew is the CEO of a company called Topnician. Topnician takes scattered corporate data and turns it into usable knowledge. If you worked at any corporate company, you probably had a light bulb turn on in your head right there. There's a lot of scattered knowledge. Andrew's company is a part of the Generator portfolio, which is an extremely selective startup accelerator, guys. It's extremely selective. He also graduated from the Beta MN Startup Accelerator, and his company won the 2024 Division Award at MN Cup. So we're definitely in for a treat. Thank you, Andrew.
All right, hi guys. Quick show of hands here. How many of you would consider yourself a developer or somebody that's building out a product? Okay, so that's most of you. Okay, and keep your hands up if you would like somebody else to use what you're building someday. Okay, and also keep your hands up if that involves somebody buying that product. Okay, and that's about what I thought. So one of the things that we're going to be talking about here today is why it is so important that you make your product actually usable. And that might seem like something, well, okay, yeah, duh, but it plays a big part into actually driving adoption here. So we all know that AI is an incredibly powerful tool. You can use it to do a bunch of different stuff. But I think that it's very important for the builders in this room to understand that we are in the tiny, tiny minority of people that actually use AI in the way that we do. Okay? And I think that it's also important to recognize that as you grow, as your company grows, as the number of people that would be using your products tends to grow, you are going to be encountering less and less, I guess, technically savvy users. But you have to meet them where they're at, and you have to make your product as valuable to them as humanly possible. Right? So how do you actually do that? Well, there are a couple of different ways you can do that, but it's important to remember that like 80% of people never even change the settings on their iPhone, right? So it's really on you to make sure that you can meet the customer where they're at. So one of the things we did with Topnician, right, is we wanted to make it that every, I guess, person in that company that might not have a technical background can access all of the data, all of the information that lives within their siloed, I guess, branches in that company, even the more tacit knowledge, more procedural knowledge, and it's as simple as talking to a coworker. So one of the biggest unlocks we had recently was our voice agent, and we actually saw, I guess, adoption shoot way up because we were meeting some of those, I guess, less complex users where they were at. And I guess our assumption is that there are a lot of people out there who are very, very competent in their jobs. But unless you make something that is going to, I guess, appeal to them, then they're not going to use it, even if what you have is extremely powerful. It's rarely the best product that wins, but it's the product that's best positioned in the eyes of the user that wins, if that makes sense. I'm sure that anybody that uses Linux will probably tell you the same thing. If you guys have any questions about what I'm talking about, I'd be more than happy to have a conversation with you afterwards about this. But it's something that I've seen time and time again that I think just never really gets touched on. And especially as builders, we have to keep this front of mind when we are doing anything with this. It's not necessarily about us, it's about our users. And even if you're dealing with very technical users, it can still play a factor. My brother, my co-founder, some of you may know him, some of you may not. His former job was at a geotechnical engineering firm before he started this company with me. And at that firm, they have an internal software tool that is used by PhDs, some of the most technical people you will ever meet. The number one complaint, and these are some of the smartest individuals you will ever meet, is that they do not know how to use the damn thing. There are tools on there that power users have no idea, have never touched before. And if you hide behind that, it's going to really bite you at some point. So yeah, that's my TED Talk. Happy to talk with you guys afterwards. Feel any questions you guys might have.
So you said it was important to meet people where they are. How do you do that? Like, what are your tools or techniques for that?
I think one of the biggest things is you try to go at the level where you observe how they use the tool when you're, I guess, not walking them through anything. You need to be as intuitive as possible. Try not to interrupt their workflows if it's something that's related to productivity. Try to fit it into how they already do their work. The worst thing you can do is be a disruptor in what they otherwise do. Otherwise, you're going to get your 1 year, 1 up. You're going to see like 15% adoption, and the decision maker who pulled the trigger on you the first time is going to say, "Yeah, I don't think we're going to, be going with you guys going forward anymore." And then that recurring revenue that you have is all of a sudden not recurring revenue. And that's one of the worst things for people that built out a product that they're in love with, and then you see we're just not seeing the adoption metrics that we want to.
How important is process engineering? We often come across users that use these huge processes with 15, 20 edge cases where in reality 20% of the process can give 80% of the value. So
yeah, that is extremely important. And I think that one of the biggest things you can do is, you guys have all heard of the Pareto principle, right? Where it's like 20% of the fruit in an orchard would come from or 80% of the fruit would come from 20% of the trees. It's kind of like that. If you can make something that addresses a lot of people's needs really quickly, and it's like that, 20% effort for you, that's going to move the needle so far in the right direction. You can work on those edge cases, but understand what's actually driving value early on, and especially if you're operating in a constrained resources environment. Back there somewhere? Say it one more time.
How does having voice communication help with that?
Yeah, so one of the things we saw was that, for, like I was saying, 80% of people never even change the settings on their iPhone. And there is a large, and I do mean large, contingent of people out there that they don't even feel comfortable using ChatGPT on a regular basis. Okay? And for those people, what do they feel confident doing? If you work it into their existing workflows where they're not opening up another app or anything like that, they're not going to another website, but they can just interact with the voice agent, and hey, it's like I'm talking to Jim over here, right? Hey Jim, can I see that report, or can you send out an email, or send out, update these records in HubSpot, anything like that, right? And so it's just understanding, okay, well, what is the hurdle that would, limit adoption here? And sometimes it's not what you think. it's almost never what you initially think. And that's why it's so important to spend time with your customers and understand on each user level, okay, well, what are the barriers here? Because it is never what you expect it to be. All right, thanks.
Okay, and that's that. That's our lineup today. As everybody knows, Wild AI is a free event. We do get questions about sponsoring. I just want to say, if you want to help Wild AI, the best way you can help is by coming, bringing your thoughts, bringing your friends, encouraging people that have interesting things to say to sign up. That's what matters. We have a registration link up here, so feel free to scan that QR code. As a reminder, Wild AI is the third Monday of every month. We had a fourth speaker. Her name is Sarah Kaya or Kaja. I can't remember her name. I don't know how to pronounce her last name. But she was supposed to be here. She couldn't make it. Sorry.
Are you going to let me give an update on the heat map?
Oh, right. No, definitely. Yeah, that's on the list. Yeah. Sorry. And then, yeah, that's about it. We do have Matt here who wants to give a quick update about a hackathon. So, Matt, why don't you come on up and tell us a little about that?
Thanks so much, Anushka. Very gracious. So I'm actually, you might think, oh, this is the guy who spoke last month. That was actually my brother, who looks a lot like me. He's a little taller. Hopefully some of you remember the Heat Map Hackathon. That's what he talked about. So his company is a health tech company right here in Minneapolis, or in Twin Cities, that he's founded, B-Data. And now with a bunch of other groups, he's launching a hackathon. And registration for this is now open. This is what he talked about last time, so that's why this is just a quick follow-up. He couldn't be here. He emailed me today, hey, can you give an announcement? So, got to help a brother out. I'll just read the LinkedIn post he dropped recently, and that is this. Registration is now open for the Heat Map Hackathon. Brought to you by the American Burn Association and B-Data Incorporated in partnership with Healthcare Minnesota, University of Minnesota, and a bunch of other places, including University of Minnesota Statistics. This national hackathon will bring together data scientists, clinicians, students, and innovators to tackle a critical challenge in U.S. healthcare: equitable access to life-saving burn care. Participants will work with real-world data to explore how referral decision-making can be improved, how virtual care can expand access, and how burn center coverage could be configured more equitably nationwide. Teams will leverage B-Data's National Injury Resource Database, along with public data sets, to identify gaps in access and turn insights into action. Registration is now open for startup teams, community members, and students. Participants may register as individuals or as part of a team. The data will be made available on February 24th, and the event will culminate in an in-person hackathon and reception on March 25th at the Walter Library at the University of Minnesota. Learn more and register, and there's a link which you can't really read out. But people can see me if they want to follow up. Also, I've worked with this data set. It's the first national aggregation of burn care data. I think it's the only one of its kind. Everybody in healthcare knows that data siloing is this massive problem. So what B-Data has done is basically, you working with burn associations, collect data from almost every burn center in America. And now the hackathon will use this data or some version of, I don't know the specifics. So I think it'll be really cool. Thanks again, Anushka, for allowing me to do this. And anybody who wants more information about what the link is, basically, just find me and I'll send you the link. Thank you so much.
Thanks, Mark. So to continue what I was saying, Professor Sarah Kaya wanted to be here today. She couldn't, but we are going to share her email address because she really wanted to speak today. I also want to remind everybody that this event is live streamed. So if there's a day you don't want to come out into the tundra that is Minneapolis, you can watch it from home. People have met collaborators here. This is exactly what Matt just said. This is why we're here. People have met co-founders here because we're not networking, we're talking, we're sharing. So thank you everybody for being here. I want everyone to look over here at Matt Osborne. If you could raise your hand. There's Ben, there's Kate, and this is all this media, all this setup, this is all because of the three of them. And of course we miss Jake today who couldn't be here. Thank you, everybody. Let the drinking and talking begin. And please reach out if you have any questions. Thank you.